Okay, Math 7. So we are moving on to section 4.3, identifying and writing proportions. So the first few examples here, your job is to be able to determine whether the ratios are proportional. So basically, in order for a ratio to be proportional, they are going to be the same. And so what you want to do is you want to reduce the two ratios that are given, if you can, and see if they equal the same thing. So for example, I know that 2 sevenths cannot be reduced any further. But when I look at 6 and 21, I know they can both be divided by a 3. When I divide 6 by 3, I get 2. When I divide 21 by 3, I get 7. So when these ratios are both in their reduced form, they're the same thing. So determine whether they are proportional, yes, and then your work shows both. I'm just going to say they both simplify to 2 sevenths. Okay, so our next one. What can go into both 8 and 24? And you just want to take it, like I know that 8 can go into both of them. So this gives us 1. 24 divided by 8 gives us 3. So this one reduces to 1/3. Now 6 and 20. When I look at them, they both can be divided by a 2. This gives me 3/10. Now, are these the same? And that's kind of your question, and no, not proportional. When you reduced them, they did not equal the same thing. Okay? Now, sometimes you might have larger ones, and so it might take you a couple dividing them a couple times to reduce them. When I look at this, I'm going to try, I know that 2 can't go into both of them, but I'm going to try 3. So I'm just going to go to the side. I'm going to take 51 divided by 3. 3 goes into 5 one time, and it goes into 21 7 times. So if I divide both the top by 3 and the bottom by 3, I get 8/17. Okay, so now, like I said, sometimes it's hard to see what they have in common, so maybe dividing by 2 is a good starting point. Half of 72 is 36. Half of 128 is 64. You could divide them by 2 again if you'd like. And I get 18. And if I divide 64 by 2, I get 32. And it's going to divide them by 2 again. I get 9. Divide by 2 again, I get 16. So 9/16 is about as small as you can get that. 3 goes into 9 but not into 16, and 2 goes into 16 but not into 9. So then you look at these two. These are both reduced. So sometimes, like I said, you might divide a couple times, or maybe you recognize sooner that a 4 went into there, or an 8. But I just was going to show you kind of like the long way. So are these two equal? No. So no. 8/17 and 9/16 are not proportional. Now, on your worksheet, you need to show me your work. You need to show me that you reduced those, that type of thing. Okay, so is the ratio of oats to water proportional for each serving? So we are comparing oats to water. So I have oats to water. And we have 8 servings and 12 servings. So I'm going to do 8 servings and 12 servings. So we have 2 cups oats and 4 cups water for the 8 servings. And then for 12 servings, we have 3 to 6. Are they proportional? Well, what do they both reduce to? 1/2. So you'd be like, yes, they are proportional. Okay. And the last one, it's finding equivalent ratios and writing proportions. So to find an equivalent ratio, you just have to multiply or divide the given ratio by the same number. So it's kind of like finding equivalent fraction. So for example, I could divide both by 2. And I would have 4/7. So it says then write a proportion. Well, 8/14 equals 4/7. That's one example. Instead of dividing, you could multiply them both by a number. So maybe I want to multiply them both by a 3, just picking a bigger number. So 4 times 3 is 12. 18 times 3 would be 54. So then your proportion would be 4/18 equals 12/54. Okay, so that proportion ends up with that equal sign in there. And then it says write 2 equivalent ratios and a proportion. Well, I mean, you could start off really simple, like 1/2 equals 4/8, and so on, but I want you to come up with your own. You can't use mine. Okay, and that's it.